In this presentation, I would like to explain enhanced data models for advanced applications. First, why enhanced data models? Because as the use of database applications has grown, users have demanded additional functionalities from existing database software packages. Day by day, data is generated enormously by different media using different technologies. Because of this, users required advanced and complex query processing applications. So, to handle different types of data in the databases, we need different types of applications that are managed with the database applications. Object-oriented and object-relational systems try to provide features that allow users to extend their systems by specifying additional abstract data types for each applications. However, they are failed to fulfill all complex requirements. Some features can be implemented to improve performance of these problems by using special database software packages. So like Data Blade used in the informatics and cartridge in Oracle database systems. Here I would like to explain advanced applications for databases concept like active database concepts and triggers, temporal database concepts, spatial database concepts, multimedia database concepts, and finally deductive database. First, database concepts and triggers. So what do you mean by active database concept and triggers? The rules that specify actions that are automatically triggered by certain events, so that have been considered for enhancements into database applications for quite some times. So here active database concepts consist of rules, and that rules are executed using triggers. Actually, the rules, they are used to specify actions that are automatically triggered by certain events. The events may be any SQL operations, and majorly they consist of update, insert, and delete operations. So these triggers are executed as and when these type of operations are executed in the database. So trigger is nothing but a technique for specifying certain types of active rules. Each trigger in the database management systems consists of three operations: the event, condition, and action. It is also called as ECA model. So the event is any database modification operation, example insert, delete, or update. And condition, so based on the event, condition is checked against true or false expression. If it is true, execute some actions. If it is false, do some other actions. And action part is a sequence of SQL statements or PL/SQL statements that will be automatically executed. So event has happened, check the event for the condition. If it is true, execute action part. If it is false, then also execute action part. The syntax of trigger is as follows. So we are creating the triggers using create trigger command in the SQL. So create trigger, any user defined trigger name. Next, after or before triggering events, on table name for each row when condition trigger actions. So in the capital letters what we have written, so all are keywords in the SQL. So we can execute one or more events, so and they are specified with OR operator, trigger 1 or trigger 2 or trigger 3, like that. And we can execute triggering events on insert, delete, update of column names or single column name or multi columns. Trigger action may be SQL or PL/SQL block. So this is one small example. Create trigger total salary 1. So total underscore sal 1 is the user defined trigger. So we can execute this trigger after insertion of on the table employee for each row. So when new.dni is not null, and update the department and set the new salary with values, and condition is where. So here in the triggers we are using insert, delete and update. The triggers are executed when insert operation, delete operation or update operation. You can specify any one. The keywords new and old are used in the Oracle notation. The new keyword, it is used to refer a newly inserted tuple. Old is used to refer the previously deleted tuple or the tuple it was before. And so you can update these triggers so using activate, deactivate or drop rules by referring to their rule names. A deactivated rule will not be triggered by the triggering event. This feature allows user to selectively deactivate rules for certain periods of time when they are not needed. The activate command will make the rule active again. The drop command deletes the rule from the system. Another option is used to group rules into named rule sets. So the whole set of rules can be activated, deactivated or dropped. And you can also have, so triggers must be executed before the some events or after the some events, or you can use instead of this event, or at a time all events with actions are executing throughout the triggering the events. So there are two ways you can execute the triggers: role level triggers and statement level triggers. In the triggering, if you want to specify row level, then you have to use the keyword for each row. So for each row specifies a row level trigger. It executes separately when the event is executed or affected for each row. And you can also use new and old keywords for the each rows. If you are not specify for each row in the triggering, so then by default it is take it as a statement level or table level trigger. So it executes once for the SQL statement. Again, so we can have triggers in different scenarios. Means, so there are three main design issues for the triggers: immediate consideration, deferred consideration and detached consideration. So if you want to execute the trigger immediately after the successful execution of the command, then we are using immediate consideration. The same transaction, and that can be one of the following depending upon the situation. So before, after and instead of. Deferred consideration means after executing the trigger, the condition is evaluated at the end of the transaction and it is updated at the end of the triggering event. Detached consideration means the trigger is executed, condition is evaluated in a separate transaction and it is not at all related to the existing transaction. So this is regarding triggers. So next, temporal database concepts. Temporal databases, in the broad sense, it includes all database applications that required some aspect of time when organizing their information. Means, So based on the time, so the database operations are executed and these time values are stored in the databases. Such type of databases operations and concept is called as temporal databases. So examples like applications where some aspect of time is needed to maintain the information in a database. These include healthcare, where where patient histories needs to be maintained, and insurance where claims and accident histories are required, as well as information about the times when insurance policies are in effect, and also the reservation, bus reservation systems, railway reservation systems, flight reservation systems. We are using these database, temporal database concepts. And not only time means it is both date and time. For temporal databases, time is considered to be an ordered sequence of points, but we are using the chronon instead of point because, so if you take time as a point, some transactions are executed in microseconds, milliseconds, or in seconds. So to use one common word, the temporal database engineers are using the chronon as a word. A time in the temporal databases is used to represent its start and end time points. So temporal databases are again divided into three subcategories: valid time databases, transaction time databases, and bitemporal databases. In valid time databases, a time is interpreted as a valid time of a database. So each activity or each transaction in the database is associated with time. So then the transaction and its values and time totally considered as valid time databases. Instead of time, if you take transaction as a point in the databases, then it is referred as transaction time databases. Here in the transaction time databases, totally at what time, what type of transactions are executed, how they are executed, and transaction IDs for each transaction are stored separately in a databases. And bitemporal databases means, so bitemporal, it consists of both valid time databases as well as transaction time databases. So find events in the temporal databases. It may be single time point event or it may be series of point events from the time series data. And so such type of events are occurred how much time, it is referred as duration of events. So this duration of events is associated with a specific time period. It represented by start time and end time. So this is one small example related to temporal databases. See, so EMP valid time. In this table, we are storing name, SSN, salary, department number, supervisor SSN, and valid start time and valid end time. So similarly, department table, it consists of all the attributes of a department and at the end valid start time and valid end time. So this is the example for valid time temporal databases, figure A, and B. So this is transaction time. So this table B indicates the databases they are associated with the transactions. So here TST indicates transaction start time, transaction end time, similar to department table also. So see, so this EMP, so bitemporal database means, so this relational database consists of both valid time as well as transaction time. See last columns. See this VST, VET, start time, valid end time, transaction start time, transaction end time. So from this three diagrams, A valid time databases, B. Transaction time databases, C. Bitemporal databases. So this is one populated database, represents the valid time database. So here VST indicates the valid start time, VT indicates the valid end time. So what are the employees and where their salaries, department numbers, their manager numbers, and when they are started, they are working in the departments. All information now indicates till date. Similarly, department, so department information. It is also an example for valid time database. So next the question is how to update the temporal databases. At what time you have to update. So there are three ways you can update the temporal databases. So first one is proactive update. Since it is applied to the database before it becomes effective in the real world, means before only we have to think about when the database has to be updated, and after the what is the action. Retroactive update means update operation is applied to the database after it becomes effective in the real world, and simultaneous update means an update that is applied at the same time as it becomes effective. And one major thing in temporal database is surrogate key attribute. So in common relational databases we are using the primary key. So here we consider it as a non-temporal primary key because that primary key value may change over time, as it is important to have a unique number. So but in temporal databases we are using one word, surrogate key. It consists of key value with the time, whose value never changes for each real world entity, in order to relate all versions of the same real world entity values. So small after temporal database, I would like to discuss about time series data. Here we are discussing the data that is related to time. Temporal databases means the databases which are using time as well as transactions. But here the values or the data that is associated with the table is called as time series data. So this type of time series data are often used in financial, sales and economics applications. So they involve data values that are recorded according to a specific predefined sequence of time points. And for handling these time series data, we need time series management systems rather than general purpose DBMS for managing such information. Means so there is a separate software package to handle time series data like TSMS, time series management systems, and the queries that are arised from these time series data, such as finding the average or maximum weekly closing stock price or the maximum and minimum monthly closing stock price from the daily information, like that. So next I would like to explain spatial database concepts. So spatial databases provide concepts for databases that keep track of objects in a multi-dimensional space. For example, cartographic databases that store maps include two-dimensional spatial descriptions of their objects, from countries and states to rivers, cities, roads, seas, and so on. So these spatial databases concept, spatial database also includes geographic data and related applications using GIS. In general, spatial databases store objects that have spatial characteristics that describes them. The spatial relationships among the objects are important, and they are often needed when querying the database. Although a spatial database can in general refer to an n-dimensional space for any n value. So here we are restricting ourselves to only two-dimensional or three-dimensional spatial databases. For handling spatial databases, we required special spatial data types and models. So, for example, data types like map data, they are used to describe the points, lines, and polygons. Attribute data to describe the attributes of a that is spatial images, and image data to store the images in the databases. And the special operators for spatial databases are topological operators, projective operators, metric operators, and dynamic spatial operators like create, destroy, and update the spatial databases. And we can query the data, means the spatial data, in terms of range query, nearest neighbor query, spatial joins, or overlays. So the common types of analysis for spatial data are to measurements, to measure the distances, perimeter, shape, adjacency, and direction, and spatial analysis and statistics like pattern, autocorrelation, and indexes of similarity and topology using spatial and non-spatial data, flow analysis in the spatial analysis like connectivity and shortest path, location analysis, terrain analysis, and some kinds of search and the spatial databases. The examples for spatial queries like what are the names of all bookstores within 5 miles of the College of Computing building at Georgia Tech University, or list all the customers located within 20 miles of company headquarters, like that. So for handling spatial databases, we are using the spatial data mining concepts. So spatial data mining concept is very helpful to retrieve data from the spatial databases, and whatever the concept that are occurred in or available in data mining, means classification, association, clustering concepts are same used for spatial analysis. Means for handling spatial data mining, we are requiring spatial classification, spatial association, spatial clustering. All are same compared to data mining applications, but here instead of data, here we are using data as a spatial. It may be two-dimensional object or three-dimensional object, including geographic information systems. And the thing is spatial outlier. It is unwanted thing in the spatial data. It is a spatially referenced object whose non-spatial attribute values are significantly different from those of other spatially referenced objects in its spatial neighborhood. Next, multimedia database concepts. Multimedia database provides features that allow users to store and query different types of multimedia information, which includes images, video clips, audio clips, and documents, etc. Images such as photos, drawings, or any cartoon images, video clips like movies, news reels, or home videos, or any videos related to functions, and audio clips like songs, phone messages, speeches, and documents such as books, articles, etc. So these databases, different types of data in the databases are called as multimedia database concepts. The main types of database queries that are needed involve locating multimedia sources that contain certain objects of interest. For example, one may want to locate all video clips in a video database that include a certain person, say Michael Jackson, or the query such as find video clips where a soccer goal is scored by a certain player or team. So such type of queries are treated as content-based retrievals (CBR) because the multimedia source is being retrieved based on its containing certain objects or activities. Hence, a multimedia database must use some model to organize and index the multimedia sources based on their contents. So, for retrieving the data from the multimedia databases, we are using two approaches. One is automatic analysis and another one is manual identification. The first approach is based on automatic analysis of the multimedia sources to identify certain mathematical characteristics of their contents. This approach uses different techniques depending upon the type of multimedia source, whether it may be an image, video, audio, or text. Second one is manual identification. In this approach, so the objects and activities of interest in each multimedia source and on using this information to index the sources. So this second approach can be applied to all multimedia sources, but it requires manual pre-processing phase where a particular person who knows the database types has to scan each multimedia source to identify and catalog the objects and activates its contents so that they can be used to index the sources. And for automatic analysis of images using techniques like RGB technique or HSV technique. RGB means red, green, blue. HSV means hue, saturation or value. So such type of analysis were used in the automatic analysis of the spatial databases. Next is deductive databases. In a deductive database system, we typically specify rules through declarative language. A declarative language means a language in which we specify what to achieve rather than how to achieve. It uses two concepts. One is inference engine and another the logic programming. An inference engine or deduction mechanism within the system can deduce new facts from the database by interpreting these rules. It is also related to the field of logic programming, second one. So this logic programming is called as Prolog language. The deductive database works based on the logic that has used Prolog as a starting point. Apart from Prolog, we can also use datalog. Datalog is used to define rules declaratively in conjunction with an existing set of relations, which are themselves treated as literals in the languages. A deductive database uses two main types of specifications, so facts and rules. So facts are specified in a manner similar to the way relations are specified, except that it is not necessary to include the attribute names. But rules are somewhat similar to relational views. They specify virtual relations that are not actually stored, but that can be formed from the facts by applying inference mechanisms based on the rule specifications. The main difference between rules and views is that rules may involve recursion and hence may yield virtual relations that cannot be defined in terms of basic relational views. So the evaluation of Prolog programs is based on a technique called backward chaining, which involves top-down evaluation of goals. So these are all some examples queries based on the Prolog and the datalog notations. Here we are using the words predicate, argument, constant, variable values. A predicate has an implicit meaning which is suggested by the predicate name and fixed number of arguments. So here this example illustrates facts and rules. So these are the facts supervise and who are all the supervisors for employees: Franklin, John, Franklin, Ramesh, Franklin, Joyce, etc. Means Franklin is the supervisor for John, Ramesh, and Joyce, and Jennifer is supervisor for Alicia and Ahmad. James is supervisor for Franklin and Jennifer. Means Franklin again works under James. So these are facts, and we are using the rules such that if X is a supervisor of Y, then supervisee is X for Y. So like this you can concatenate or sequentially form the rules. And these are the examples for queries. So if James is the superior, then what about Y related to James? If James and Joyce, how they are related to each other in the organizations. So this is the example for prolog notation. Same you can use in hierarchical or in the tree structure notations. See James, so sub roots Franklin and Jennifer. James is the supervisor for Franklin and Jennifer. Again, Franklin is supervisor for John, Ramesh, and Joyce. Similar to Jennifer also. These are the references. Thank you.